Hey guys, what is up? It's your pal Dave again, back on another Sunday in the lab, doing fun stuff, building things, you know, the usual. So what are we doing today? So if you remember last week, we built up a version of the Auduino Synth, and if you're not familiar with this, check out my YouTube page and you'll see a bunch of things. It's a cool little synth project. And we built one up using an Arduino Nano, which really simplified things, made it really simple. And I promised you guys that I would build a permanent version on a breadboard, or sorry, a permanent circuit board, so you could make your own instrument. And that's what I've been working on. And I actually went a step further, and I designed a 3D printed case for this guy. So usually in this we use the Hammond, what is it, 1590 BB, I believe, box. But I decided, you know, a lot of guys are into 3D printing now, so maybe they'd want to print their own enclosure. And I did it, and it worked pretty well. And, you know, it's a little cheaper. And, you know, whatever. So let's do that. So we're going to build the circuit on one of these. This is an Adafruit Permaproto, I think it's called a half-size board. And I really like these guys. Let me go full screen here. So these are really handy. They're a great little way to transfer a circuit from a breadboard onto, you know, in something permanent. And they're standard. The thing I like about them, that I really like, you notice how all the rows line up, right? That is so useful. Sometimes you get these boards and they don't all line up, like the header line doesn't line up with the rest, and it's kind of a pain. These guys are really great. They're, you know, small, really high quality, like gold, looks like gold plating on the connectors. So we're going to use that. And I built the case around this. So there's two standoffs, and this will fit. It will screw right into that. Hopefully. I'm hoping this is all going to work, because I've just done this on paper. So we're going to do the whole thing, and hopefully all goes well. If it doesn't, we'll just delete the video and pretend it never happened. Okay, couple of other things to take care of. Last time I was streaming, I got a donation from Steve Allen, and he did it after I went off air, so he never got his notification. So Steve, thank you. I'm going to replay your notification, because you're going to get everything that's coming to you. And I didn't mean that to sound as threatening as it did, but here we go. So there's Steve. He says, "Hey Dave, thanks for all the great videos that you produced. I'm not always able to catch your Life in the Lab series, but I enjoy every one of your shows. Fantastic stuff. Keep up the great work." Wow, that's so nice. What a nice guy. Thank you, Steve. That's really appreciated. Very nice of you. Oh, another thing. Let's go back here. No, let's go here. There we go. Okay, so rooting through the garbage the other day, as one does, I found this super cool old receipt printer. Like, this is an old dot matrix receipt printer. And of course, the first thing that goes to your mind is, I gotta hook that up to Twitter. like you do, right? Like, isn't that what you guys would think? So, starting from now, this is like kind of in its test phase, but you know, could be a part of the stream, I guess, if it works out. So what you can do is, all you have to do is follow Notes and Volts on Twitter, and then tweet at Notes and Volts. Right, it should come up in the list, and then just type whatever you want. a huge geek. And then you can do a hashtag geek for life. You know, whatever you want, right? And if I tweet this, it should print out here. Pretty cool. So then you can so I don't know if this is useful, but it was really fun and I'm glad it happened. So if you tweet to Notes and Volts, it should print out here. I can read it. It'll be fun. We'll have a good laugh, right? Maybe. All right. So that's enough. Who's that? Drugadile. Hi, Drugadile. How you doing? Thanks for stopping by today. Okay, so let's go back here. So many stuff. It's like working a TV studio and not knowing what you're doing. Okay, so this is what I did. I wanted to make this as easy for you guys as possible. So I made this sheet that basically shows all the connections to the board in simple, non-schematic, you know, easy to follow, at least in my mind, and we'll see how that works. Also, there's a cool 3D panel that I designed that you guys can print out, and I'll show you how to do that. And for all you tech guys, here's the schematic. So once this video is done, I'm gonna put links in the comments to all this stuff. You can download it, plus the 3D files to print your own case. Okay, so that's I think all the bookkeeping we need to do. So let's start out. So let's look at the 3D enclosure. Now, I use Simplify 3D for my my slicing software for my 3D printer. And what I'm going to do is I'm going to post this model on Thingiverse, which, you know, is a really good place to put it, I guess. I have to create an account and do all that, but it will get up there and I'll put the link as always. So when you print this out, you want to print, this is the top of the case, okay? This part. You want to print it out so that the top, the very top, is down on the printer bed, and it's going to build it up from there. And for you printer guys, so I used 20% infill. I used no supports. I used no rafts, no nothing, and I printed it in ABS. Okay, you probably can print it in PLA. I don't print PLA, so I couldn't say for sure, but I printed it in ABS and it works good and it's strong and all that stuff. So yeah, download the file, put it in your slicer program, send it to your printer. And then you're also going to want to download the bottom, which you're going to want to print kind of face down with the screw holes. There's little indents for the screws pointing up. Hey, Dusk Boy, Sunday night it's streaming time. Cheers from Sweden. Thanks, Dusk Boy. You're always here. What a great guy. All the way from Sweden. It's probably like 5 a.m. or something for him. So he's a real trooper. Okay, so there we go. So you do the top, you print the bottom, and hopefully all goes well, and you'll end up with this. Hopefully. 3D printing is quite a crazy thing. Okay, so let's get back to here, and let's get back to here. One day I'm going to get the hang of all this stuff. Okay, so here's what we're doing. This is our goal, and we're going to this stream will be a lot of soldering and building. Oh my God, someone's tweeting. Jack Halkabar, great stream, great content as always. Cheers from Hungary. My God, look at that. So this is my first tweet on the dot matrix printer. Pretty cool. Thanks to Jack for that. That's super awesome. It works. That's cool. Like I said, just follow Notes and Volts on Twitter, and then start your tweet with @NotesandVolts, all one word, and then tweet whatever you want, and it should print out on the printer. Because no reason other than that. Okay, cool. So let's get started here. Now, is there anything I have to explain? No, I think we just go. We just do. So, like I said, this is built on the Arduino Nano, and really nice little board. I'm really liking it. It's basically a Arduino Uno compatible board, and they're cheap. You can get them on eBay, very cheap. I'll put links and all that stuff. But I got this, and literally it was probably less than $5. And it's not, for those wondering, it's not an official Arduino. It's a knockoff. All right. So it comes like this with some headers, and we're gonna have to put the headers in and solder it all together onto the board. It also comes with programming headers, right? This little six pack of headers. We're not going to use them. We don't need them. Okay. Good. Everybody happy? So before we do anything, we're going to program up our Nano. Okay. So let me get some stuff ready here, and I'll put the links to the program as well. Man, this is getting complex. Let me just see where I put that. All right, I'll show you where you can get it anyways, if ahead of time. Let's see. So if you go to notesandvolts.com, sorry, if you go to Notes and Volts YouTube page, and let me pull it up here. Hold on a sec. All right. So let's go to YouTube. And let's do a split screen here. So I just got to remember where I put the program file. So if we go to YouTube, let me do this properly. And you go to Notes and Volts. You're already there because you're watching this stream. And you go to my last thing. What is it? 3D live from the lab, Arduino Synth build. Blah blah blah. You need a website. Why not? Plays ads. Why not? Where's the software? So if you go follow this link, you'll get to this page where you can download this software. Let me just put it somewhere. All right, so now we got the software. Let me get rid of this. Got like 50 million windows. All right, now where did it go? I got a million icons, 50 million windows. And where did you go? Hold on a sec. Let's see where it downloaded to. Just give me one sec here. Where's this download tab? Come on, man. All right, let me try it again. All right, so it did go to my desktop. I just got so many icons I can't find it. There it is. Okay, so let's extract it. It comes in a zip folder. All right, and we'll open it up in the Arduino IDE. Simple as that. That was so painless. Okay, I'll get rid of all of this, bring back this. All right, so there we go. Here's the software. And we're going to upload this. So you notice Auduino Midi upgrade. So it's got the Midi mod and all that stuff. And why have I got this ugly window up? Requires the Midi library. So I've done tutorials on how to install this. If you don't have the Midi library, watch my videos on Midi. It will show you how to install it. I think it comes, the Arduino IDE comes with it now. So yeah, it should be fine, but you need this, include midi.h. A couple of things. There's a dip switch option. Dip switches are these guys. It's a little 4-position switch. This allows you to change the MIDI channel without reprogramming it. We're going to add that. If you don't want it, you set dip switch installed to false, right? And that way you set the MIDI channel that this will permanently be on in here. So right now it's on 1, but we're going to install the dip switch. So we're going to say true. Okay, so now it's true. Make sure it's like it turns blue. That means it was accepted as a command. And now we can upload. All right, so let's plug in our little nano board. You should get the USB sound of success. And go to your tools library. Make sure the board type is set to Arduino Nano. Make sure your COM port, it should detect automatically. If you got a few COM ports, make sure it's the right one. If it's the wrong one, it won't go through. You'll get an error. And let's upload this and see what happens. Now watch for the little flashies on here, the RX and TX lights. And they should do a little something once everything's compiled. There they go. And you should see done uploading and no error messages in the bottom here. And we got that, so that is great. Remember, dip switch is true. Everything is good. Everything looks great. Okay, so let's get rid of that. We don't need that. We can unplug our board. Should be ready to go. Who's that? Juanca. Thank you for subscribing, man. Really appreciate it. Thank you. And I butchered your name, I'm pretty sure. Okay, so let's go over to the other bench. We haven't seen that bench in a while because I've been doing more designing stuff, but look at this, a solder bench. And Kluski test 3, haha, yeah, he's because I was doing a bunch of test things, so I was having trouble with my chatting program. So thanks, man. Okay, let's see if I can do this. Full screen, solder view, engage. All right, this is the solder bench. I have a soldering iron here. It's a Heiko 888. I like it. It's good. Now, just say in the chat if I move out of frame, just let me know, because I sometimes forget. And let's start building. And one thing, let me get my diagrams, and can I get my, there we go. Perfect. All right, so here's the build diagram. You may want to, I'll put a link to download all this stuff, and here's the schematic for the technical people. And yeah, this shows you exactly where everything should go on a Adafruit Permaproto half-size board, which I designed this all around. Okay, so first step is we're going to place our Arduino Nano. All right, and if you look, I don't know if you can see that clearly, but basically I want the pin D13 to be second row, second B row, seventh pin over. Okay, now let's look at how we do this. Now when you're installing headers onto a chip like this, you want to make sure they're straight or it won't fit into the board. So a good way to do that is actually place the headers into the board first. Right, the long side goes down into the board. And then put the thing on top. Right, now everything's nice and lined up. And we can get to soldering. So double check. So pin 7. Yep. B7. All right, cool. So what I'll do is while it's kind of up right here, I'll tack the top and I'll put on my geeky visor that helps me see. Hello, yes, David, this is cool. Thank you, man. Thank you. Welcome. All right, and you get here, and we're just going to tack a corner pin. Make sure you get a good solder flow, and if you're brand new to soldering, you may want to do a little test, do a couple of sample joints before you tackle something like this. And you want something with a nice sharp tip, right? Because these are small pads. Now I'm going to tack the other side. The trick to soldering is apply enough heat for the solder to flow, but not enough to scorch anything, because if you leave the iron there too long, you can do some bad stuff. All right, that corner's done, and let's do the final corner. And I got a little pot of metal shavings, which helps you clean the tip. Very important. You want the tip to be nice and shiny and clean. Okay, so Here we go. You notice now it's kind of assembled, right? And it fits nicely in the board. Let's make sure. So now that I've done that, let's tack the bottom. So you want to make sure it's sitting nice and flat. And here's a great tip. Use some painter's tape, blue painter's tape, to hold things in place while you're soldering. Because I'm going to flip this board upside down, and gravity is not going to allow this to sit properly. So I'm going to blue painter's tape it down, make sure it's nice and flush. All right, there we go. Now I can flip this over. And these like soldering jigs are also handy as well. You want to keep things from moving. And let's do a couple of pins on the bottom here. It's kind of like surgery. All right, it's kind of tacking the corner pins. Make sure you don't get solder bridging between two pins. That will be very bad and things will not work. All right, now I can take the tape off, and there we go. It's all nice and flat. Perfect. Yep, great. So now that we've got everything kind of tacked, is the kind of zen part is I just have to go through and do all the pins. So talk amongst yourselves. And these are super tight pins, so my sharp tip really is helping out. What I kind of like to do is I kind of do them on I go from one side of the board to the other. That way you don't get a lot of heat buildup in any one location. And you don't want to overheat anything, because you can damage stuff if you cook it. And usually I have a fume extractor fan going to stop me breathing in all this stuff. But for your guys and the noise, I'm just going to tough it out. And it's not like there's a kind of a misconception that since the solder has some lead in it, you're breathing in lead fumes, and you're not. Like it's the actual fumes coming off is the what's called the flux, which is a chemical that kind of helps clean the pad as the solder melts. And check all your joints. You want the solder to flow on the pin and on the pad. And this is definitely the biggest soldering job that we have, because there's a lot of pins. So the rest will be nice and smooth. All right, another thing is you want to make sure you heat up the pad and the pin equally, because solder will only stick to things that are hot. All right, so if you try to stick it on something like that's not warm or hot, it will stick to the hot thing, not the not hot thing. What's the cold thing? Is that how you say not hot? All right, almost done the top here. One more. Perfect. Great. And you know, I like to do a quick visual inspection, make sure nothing looks weird, nothing's bridging, no solder where it shouldn't be. All right, that looks good. So now we'll flip it over and we'll do the bottom. And this is a lot less fussy because, you know, I'm not near the components on the board. And this must be just thrilling for you guys to watch. But it will get better once we do this part. All right, one side. Let me flip it around. And we're heading into the home stretch here. All right, I'm on a roll. How many more? 4 more. There we go. Now, once again, do a quick visual check, especially for bridges on this side. No, everything looks good. There we go. Step 1. Okay, perfect. Now, the next thing we'll do, you may notice there's, who's that? Kevin Oldman. I have a similar soldering iron. The FX888D works great. Yeah, man, like I love these things. They're not expensive and they work really well. So I don't have the D, like I got the old analog version, but the D is probably the one that took it over. But Hakko irons, Hakko, I can't recommend them enough. Okay, so next step, if you thought that was exciting, well, hold on to something because we're gonna have to cut some jumper wires. That's a thrill. Okay, so what we're going to use is 22 gauge solid core wire. So wire comes in 2 types, solid core and stranded. And the solid core is good for stuff that's not going to bend a lot, like jumper wires and stuff like that. The stranded is better, you know, it's like a headphone cable. It, you know, kind of, it's a little more flexible. And you want some wire strippers. Okay, these ones are cool because they have a little, they have the gauge markings on top, so you know where to go. There you go, stripped wire. Now, I'll show you a little trick. Where's my... never find anything. So you want to bend your wires at a nice right angle. So where you, right where you stripped it, bend the bare wire across so you get a nice, I'm using this as a right angle, you get this nice bend, right? Now you got to think how far do you want it to go? So let's do this wire here. So we're going from this red strip here to pin 28 there. So if I stick that in, what you can do, you want to strip just enough insulation off that you can bend the other side and get to the hole. So what I do is I use my fingernail and I just kind of mark, you know, exactly where that hole starts. And then you can cut it a little long. And then we'll strip the end right at that mark we made with the fingernail. If I can see it. There it is. And it's a little harder to strip that end just because we got nothing to hold on to. And there we go. So now we should have a nice fitting piece of wire. And that goes where positive rail to pin 28. Look at that. It's almost like I know what I'm doing. Almost. You want to make sure the insulation kind of protects any holes that the wire fits over. 28, good. Now we can solder that. You may want to use some tape, never hurts. Or you can bend the leads. And just solder it like you would anything else. Okay, there we go. And now you can, this excess, you're going to cut it off. So get some side cutters and cut it flush to the board. And there we go. There's our jumper wire. How are we doing? The stream is okay. Yep, everything looks good. So now we do more of this, and we'll do all our jumpers. Actually, let's do the jumpers on this side, and I'm going to use a couple of colors for power. I'll use red for power, green for ground, and that helps you kind of visually make sure you've done things right. Okay, and where's that going? Pin 25 between ground rail, and there. What I should have done, I should have pre-cut a lot of this stuff so you guys wouldn't have to watch me do it. But it's a learning experience. Think of it that way. So this time this is really short, so I'm gonna hold it in the pliers so I got something to pull against. There we go, little thing. And where's that? Pin 25. And there we go. What's that? TrueTech synths rule. Yes, they do. And he's making a custom synth. Thanks, man. Thanks for explaining what I'm doing, because sometimes I forget. All right. Okay, there we go, and we'll clip it off. All right, we're getting there. Now let's do this set of wires here. There's a little jog of wires that we have to do, and I want to do that before I put the chip in. So for those, this is the MIDI circuit here. All right, this chip here is our optocoupler, because we're building a MIDI input, and the optocoupler basically protects your circuit from whatever the outside world throws at it. I use some blue wire for signals. So yeah, super useful. Let's do, I'm going to put this in place just so I get a reference. It goes there. You always want to double and triple check stuff. And yeah, that's a real small one. You know, this is like, I hate the wiring, cutting wires, totally not fun. But, you know, if you get into this hobby, you're going to do a lot of it. So learn to love it. All right, so that goes from pin 6 to past the chip. So that TrueTech Taurus pedals, I think, would be a good project. Yes, I can do my Don't Stand So Close to Me intro. What else was Taurus pedals used on? Rush, I'm pretty sure, used them on a bunch of stuff. Who else used Taurus pedals? What are you doing, man? I'm trying to solder with a piece of wire. Losing it. And of course, like over your electronics career, you'll snip wires and they'll fly to places and you'll never find them. They will just be gone. You'll never see them again. Until one day you step on it. All right. I keep telling you this is going to get more exciting, and it will. This time I'm serious. All right, almost there. All right, that one worked well. That was great. All right, one more over this side. So what I'm doing is I'm kind of bridging a, what's that? That jig for soldering looks very helpful. It is. I got this off eBay and it's, I like it. I used to use other things, but I like this one now. Maybe I should put links to some of this gear somewhere. All right, so on our board, right, there's a pin marked RXD, which stands for receive data, I think. And that's what we need this wire to go to, because we're going to receive our Midi signals into that pin. All right, so I'm going to do this, and then I'm going to solder some chips to break up the flow. So this is kind of where custom circuit boards come in handy, because the wires are not in the equation. What's that? Hills Workbench? Yes, at least a search term if not a link. I'll put a link. So if you don't know, I'm Notes and Volts is a Amazon affiliate for all you people in the States. So I'll put a link, and if you buy through it, it costs you no extra, but Amazon kicks me back a little something, which is super nice of them. But I'll do that for sure. I'll put my favorite tools. RXD. Yes. Okay, so that completes that little piece. All right, so what we just did is this little elbow. And now let's do something, let's do this whole MIDI part. So what I have here is a chip socket. And this allows you to solder this in place and then press fit the chip in after. And you don't have to use them, but I find optocouplers are a little delicate. So if you can, you know, like pull one out, put another one in, if something goes wrong, then that's pretty helpful. And it also takes some of the soldering heat, like that you don't have to heat up the part when you install it. All right. Also notice that every chip has a mark on one side, right? That's the pin 1 mark. You want to make sure that you find it and that the chip is pointing in the right way. If you put it in backwards, it's going to be bad. It won't work, and at worst case scenario, you could damage the device. The chip socket also has a little notch, so I'm going to put that in the same direction as the notch on the chip so I can remember. It's kind of a little helpful thing to stop you installing things backwards. Once again, I'll tape this to hold it. Let's flip it over. And quickly solder the corners. All right, there we go. Double check, make sure no bridges, as always. What's that? Pin 1 is power? Not necessarily, right? Every chip is different. So you have to read the manual for each chip to figure it out. So on my schematic here, there's, man, hold it the right way. There's the chip. You can see that, and it's numbered, all the pin numbers. So pin 1 in this device isn't actually used. So pin 8 is power, pin 5 is ground on this guy. It's a little weird. Optocouplers are a little different. And they're super cool, actually. So what an optocoupler does, on one side there's a little LED inside the chip. You can't see it, but it's inside. On the other side there's a light detector, and when the LED gets data, it flashes on and off, and the detector detects it on the other side and allows current to pass through a transistor. So data is passing through this chip, but no electrical signal is passing through, only data. So it's isolating one side from the other, which is pretty cool. That's pretty smart. All right. Now what else? So pin 7, we have a 1K resistor going to ground, right? Where's a 1K? There's a 1K. 1Ks have the color code, so resistors have little colored bands. Probably can't see that, but this is red, black, brown. And I'll show you something important. If I can find my multimeter. When you're new and you're not sure if you have the right resistor, or you can't see the colors correctly, or put your multimeter on resistance and measure right? You want to make sure. Don't try not to guess at stuff. And we got signal, so 1.004K, which is close enough to 1K where I come from. Okay. So let's place that. So that goes from ground to pin 7. And I want to find my little bender thing. There it is. Here's another useful tool. It's a component bender. So you put the component in the middle slot here, and then the spacing kind of gets wider as you go out, and that allows you to get a really nice clean bend. What's that, TrueTech? Reminds me of a light bulb in a Morley power watt pedal. Yeah, they used to make custom like optocoupler kind of devices back in the day. That's a little wide. But yeah, I was 'cause I remember they used to stick a little light in a plastic tube with a detector on the other side, and it was kind of like a do-it-yourself optocoupler. And I'm having trouble with this guy. This guy's been bent so many times, doesn't know which way to go. Let me try it again. So the optocouplers in these guys are custom designed for data instead of analog signals like the old Morleys used to be. What's that? You used to leave the pedal upside down and wave hand past it. I hope you were you on stage at the time? That would be cool. Where are we going? All right, I think it's going to fit. Yes, perfect. All right, that was more of a hassle than I thought it would be. All right, cut the leads. There we go. One resistor. What are we doing? So the next resistor we got to put in place is this guy. If you look on the schematic, it's a 470 ohm resistor from the 5-volt rail to pin 6. And I think the colors of 470 are yellow, purple, brown, I believe. Once again, don't guess, take a measure. $470 ohms, perfect. So it's that True Tech hacking around jam sessions. Yeah, that's good times. I'm guessing you're a player. You in a band? All right, let's get this kind of straightened out a little bit. And 2 red, 470. So I always double check stuff because getting it wrong is really annoying. Once again, we'll use the tape trick to get everything in place. And then we're getting close to finishing the Midi part. No band now, just had a few local bar bands, things in the past. Ah, yes, I can relate to that. The good old days. Okay, so there's our little section here done. And we got that done, so let's do the top part. Okay, so let's do our diode next. So this is a, what is it? A 1N914 diode. Now, if you look at the sheet here, this diode is basically between pins 2 and 3. Okay, very tight spacing. So we're going to have to use a little trick. What we have to do is we're going to stand the diode on end. Now, diodes are polarized, right? There's a negative side and a positive side. The negative side is marked with a black band on this one. So you want to make sure, and you can see in this diagram, the black band is on this side on pin 2, and you can see it here. You know, to double check the schematic, black band is marked with this line. I don't know if you can even see that. But anyways, so we want to put the black band on pin 2 and the other side on pin 3. And the only way to make it fit in that tight space is to stand it on end. All right, see that? So it's kind of standing up. All right, and that's fine. That's a totally legitimate way to install stuff when you don't have space. Let me just double check that. Black band on pin 2. Black band on pin 2. Good. All right, that looks good. And we'll cut the leads. And they go flying across the room. Well, there you go. Perfect. Now we have a 220 ohm resistor, which I believe is this guy, but I'll double check just to make sure. $220 ohm, good. And that's going to go in this area. Let me just bend it using my handy bender. All right. Where are we? It's just a flesh wound. Your arm's off. No, it's not. Okay, that looks good. Is that right? Between pin. All right, this will complete our Midi circuit. Okay, looks good. All right, so there we go. This part done. We're half done. And what should we do next? All right, let's go back, do these little power connections. So if you guys don't know, on these breadboards, these two bottom strips are basically all connected. So this red one is all connected. The blue one here is all connected. Same with these two. These guys are connected vertically, right? So we use these outside things for power rails, right? So that way anything connected, we can connect anything along the way to the red power rail for positive voltage and blue power rail for ground. Just want to make sure my stream's okay. Yep, any dropouts, any weirdness? Look at that, no drop frames whatsoever. YouTube is great. You know, they do some weird stuff sometimes, but when it works, it works well. So I also stream on Twitch sometimes, but that's more just me in the lab building stuff and, you know, figuring stuff out, real relaxed, no big agenda. So if you like watching a guy stare at a computer screen with a confused look on his face, then come on by. You'll love it. All right, let's do this little power wire. You know, this is the part of the build where you got to be real kind of zen about things. But it's great having you guys here keeping me company. That's makes it more fun. Okay, so this red wire, we're going to connect the 5-volt pin on the Arduino Nano to the 5-volt rail. So that's gonna, 5 volts is gonna come out of that pin and power that whole rail. So anything I hook to that rail will be getting 5 volts. Which is good. That's what we want. All right, good. Now we're going to do similar to the ground pin GND, and that's going to hook to the blue rail here, and everything on that rail will be connected to ground. What's that, Dust Boy? Have you ever talked about what cameras you're using on the stream? No, but I could talk about it now because what the hell, I'm just stripping wire. So I have 3 cameras. I have a, they're all Logitech, so I have a 920, C920. I have a C922 and a C930. So this guy's a C930. And my other bench is a C922, and my face camera is a C920. Now, you may be like, why did you do that? And it wasn't intentional because I basically got them at different times, right? So I just got the most recent camera that came out. And, but it had a useful thing. Now, has anyone who's ever tried to hook more than one C920 to their computer, you'll come up with a problem in that the driver will only recognize one. So you'll only be able to change the settings on one camera. You can't access the other ones if you have multiple C920s hooked up. So by using 3 different models of camera, I can get around that problem. And, you know, the drivers recognize them all separately. And that was just a fluke. I didn't even, you know, plan that. That just kind of worked out. Now, I believe I've read that the new C922s, you can hook multiples up, but I haven't tried that myself. But yeah, like hooking up multiple cameras is a pain. And a lot of people, like, you know, they've come up with some custom drivers and stuff, like trying to solve that problem, and it never kind of worked that well. So, you know, I stumbled across the solution totally by accident. Which is great when that happens. Made this wire a little too long, but nothing that a little aggressive bending won't fix. You know, I always wonder, like, how am I going to compete doing this with girls who do dances for subs? You know, like, I got nothing to offer. Oh man, we're gonna have to use some extreme measures. All right, that was a pain. Okay, there we go. Ground, she is done. Okay. Now, what we have to do is we're going to hook up ground on the other side. So there's actually two ground pins that are connected, so I can actually bridge the ground to the other ground rail on the other side. And yeah, that's then we'll have two places to put our ground. And then we're getting, you know, we're slowly getting to the end of this, which is great. All right, let's do that. Okay, so let's go ground to ground rail. Perfect. Okay, there we go. Why did I use blue wire? Did I use blue? I did. Doesn't matter. It's fine. Okay. Now we can work on the output section. This is the audio output section. So that comes from D3 is my output pin. And we're going to jump it along here to this little section of resistors and caps. And what those are is a little low pass filter. And that helps. The output of this thing is crazy, has some crazy high-end distortion, and the little low-pass filter kind of takes care of that a little bit. I'm gonna grab a drink of water too. What's that, Dust Boy? Do you disable audio on the two cams and just use the mic on the third one? Oh man! So yeah. Audio is a whole different bag. It's you may notice I'm wearing a lapel mic, right? That goes into wirelessly into a mixing board. A Behringer something. It's for their USB 16 channel mixing board. So I don't use any camera audio at all. Not at all, because it's terrible. And that goes directly into my OBS studio. So that way, wherever I am in the room, you can hear my lovely voice. What's that, Bo Anders? Welcome. Have you ever thought of making a series about building a modular Midi synth with Arduinos? Yeah, like I have. Like I've been wanting to get into modular synths forever, and it's one of those things. Like I think once you start, like that's a path you're gonna go down. It's gonna consume your life. And many dollars. But yeah, like I've been looking at modular stuff and it looks so cool, and I want to try my hand at it. Most of the stuff I do is Midi, so I don't do a lot of CV gate stuff yet, but I'm planning on it. I just got to kind of read up a bit. I know there's a lot of CV Gate fans out there now. Where'd my pliers go? I just had them. Where'd they go? Oh, they're there. All right, this is a big wire, so we gotta hope we cut it correct. Oh, look at that. Perfect, first try. So I'm actually bridging that wire from D3 just past the pin past D12. So it kind of looks like it's on the board still, but it's not. I'm actually past it. And then we'll pick it up in our audio circuitry at the other end. I'm going to tape that. So to further Dust Boy's question about audio, one thing I did is I do a weird thing where I loop the PC audio back through the mixer. So that way, you know, usually if you're using OBS Studio, you have two channels. You have your PC audio channel and you have your mic input channel. And the issue with that is if you're doing complex stuff, like you're mixing the output of a synth or a DAW or something with your mic, and you can't really tell how loud you are. You can watch the meters, but you can't tell how loud you are in relation to everything. So that way, everything goes through the mixer. I can take a direct headphone out of the mixer and hear everything. My voice, the computer, anything into the mixer, I hear everything and I can mix it better, right? If that makes sense. It's a little complicated, but I like it. It takes a lot of the guesswork out. Now there's my resistor. So what do I need? I need a 2.2K resistor. What's that? Hills Workbench Audio is my biggest issue. Still using camera audio. So you're using digital audio recorder or computer to capture audio. So I use a Behringer Onyx 16 something mixer. It's a USB mixer. everything, every audio source goes into it, and then I go USB into the computer from that. And that way you have a lot of control over stuff. All right, this is 2.2K resistor. So Hill's workbench, I'm guessing you're a maker type guy. Like, what do you do? It's nice to have fellow kind of techie dudes hanging out. What's that, Hills? I love analog projects, especially with ring modulation. Yeah, for sure, man. Like I said, I definitely want to get into it, and you know, I think that's something I'm going to pursue heavily in the future once I get a little bit of time. I have a feeling once I get into that, like, it's going to consume my life. All right, there's that resistor resisting. And what else? So now we have this big 100 microfarad electrolytic capacitor, which is a polarized component. And I don't know if you can see that, but there's a big stripe. It says minus, right? That's the minus side. And on my diagram, there's a plus and a minus. Make sure the minus leg goes to the minus terminal. And if you, this is the tallest component on the board, so it just fits in the enclosure. If you find you don't have enough, you can leave a little extra leg here and bend it over, right? But I think we'll be okay the way it is. All right, guys, believe it or not, we're almost finished the board. What's that, Dust Boy? Thank you, Dave, for tonight. It's almost 4 in the morning here. Checking out the rest tomorrow. Sure thing, man. Good luck. Have a great night all the way in Sweden. Dust Boy is great. He's always here. He's such a cool guy. He's becoming what you would call a regular. All right, so there's our electrolytic capacitor, and now we have a film capacitor. Right, not polarized, so you can put it in either way. And this is 33 nanofarads. And this, along with that resistor, forms the low pass filter to make the output a little nicer and more musical. So I'm going to do it like that. What's that, Jamie H? How you doing? I built a MIDI controller last week after watching your vids. Worked perfectly. Awesome, man. I was wondering, have you ever tried using roading encoders in the Arduino instead of pots? Yes, and I have, and I want to add that to the code because, but the problem is they take up a lot of pins, so it's hard to get a lot of them. So maybe it will be like, you know, a bunch of normal pots and a few rotary encoders, one or two, right? It's hard to get a whole bunch of them. What's that? Jack says, even though this project could be easily modified to receive CV gate from Auduino Synth, maybe in a future video. Yeah, for sure, man. Like I said, I want to get into CV gate stuff because a lot of modular stuff uses that, and you can incorporate stuff a little easier. So yeah, I'll definitely, it might be a cool little thing. And Hill's Workbench says, long time YouTube used to post electronics video under Hill or Stream, but now on this separate channel, doing a lot of audio stuff now. Back to AT Tiny soon. Cool, man. I'll have to, I'll check out your stuff. Ah, you know what? Did that on the wrong. All right, time for some rocket surgery. Desoldering gun, Hiko 808. Now you get to see the ugly side of electronics. So what I did is I put this, you know what, I could leave it. Yeah, I'll leave it because it's not gonna change stuff. I'll show you how to desolder anyways. So this thing, you basically put it over the pin, it melts the solder. There's a vacuum pump that sucks it out. Really good, handy tool. Yeah, it sounds great too. Come on. Thing is, it's a little, the wires are a little splayed out. I'll just hit it with an iron just to melt that. There we go. She's out. Now the trick is, I've already cut the leads, so I gotta be really careful. But there's enough. This is why I always want to check twice before you solder once. All right, there we go. Let's double check that. Yes. I gotta put this somewhere where it won't burn my house down. Comes with a little bib. Let's put this over here, let it cool down. we'll pretend that never happened. Sad James says, thanks, Spectrid with rotary encoders. Don't know much about them. I guess they could be multiplexed. That's the thing. It is hard to multiplex them because you have to read 2 different signal pins at once to see if it actually changed. And you can't multiplex 2 pins like that. You have to kind of keep on them because as they change, like there's 2 pins. Oh, turn on your iron, man. Come on. There's 2 pins that kind of change opposite of each other, and that's how you can tell which way they're going. They're rotating. So yeah, they're hard to multiplex. Hills says, I have to upgrade my aging full-time Tower XP machine too. Yeah, I miss XP. There's a lot of less updates. Okay, there we go. Just like did it perfectly. Nothing bad happened there. Okay, let's do the bridge to ground and then this, and then we're done with this board. So let's do some green wire. And we'll bridge the middle. And we'll fit this guy in, hopefully. There we go. Sometimes you have to give them a little persuasion. And one more wire jump to ground. And that's our audio section done, I believe. What's that? Jack says enclosures are easiest to read using shift registers through the SPI bus of the micro. That's good to know. Yeah, like I said, they're a little weird, but I'll have to take that down and explore it. Thank you. All right, this is a real short one. And I think we're almost done with the wires. All right, it's hard cutting the really small ones. It's easier to cut long ones than small ones. Does that sound rude? All right, so we got that to ground. Let's solder that. All right, there's that. That's that. Done, done. All that is done. So we got one last thing to do on this board, which is our dip switches. So we're going to position these so that pin, you notice they're numbered, right? So pin or switch number 4 will go to D12, and then along D11, 10, 9 will go 3, 2, 1. And one side of the switch will be on the ground rail, and the other side will go to those pins. Let's double check. Yep, good. And this will switch our Midi channels. Remember, we set it in the software earlier to expect a dip switch. All right, just soldering it like a IC chip. All right, looks good. And I think that's our board done. Actually weighs quite a bit. So there you go. We just did that. Now the next step is the external components. And that's a little easier. Oh, one thing we got to do is go to the right thing. We have to install our optocoupler in the socket. So there it is, right? Once again, we need to find our pin 1 notch, right? Here, sometimes it's a little dot, sometimes it's a little cutout, but one side will be marked. Make sure you put it in the right way. Now, one thing also, when you get a new chip, the legs are kind of splayed out a little bit like that. To make them fit, what you do is you put them on a flat surface and you kind of roll the chip and bend the legs in a little bit so they're a little straighter, right? And then if you do that a few times, you'll get it just to the point where they'll fit into the socket, and then you can kind of press them in. There you go. And it should seat, and you want to check that all the legs are actually into the socket, not bent out. Because sometimes you push it in, the leg will bend under, and then you're gonna have a bad time. All right, there you go. Pretty cool. And let's double check. Am I missing anything? Nope. Nope, that's all pretty good. Okay, so the rest of this is going to be external components, the pots and all that fun stuff. And how are we doing here? 2 hours. Good God. Okay, so what I think I'm going to do is I'm going to finish this up on the next stream, because otherwise this will be like a 4-hour stream, and that's a lot of me to deal with. So let's we'll finish it up next time, probably this week, around 8 o'clock sometime, or 9, and we'll just finish it up. Sound good? Let me just double check. All right, let me get. So there you go, guys. That was a lot of fun. I got some new people here. It was great to meet you, and hope to see you next time. But we'll continue this on, because I don't want to rush through it and do a horrible job. So we'll continue on next time. We're going to build a front panel, right? And I'll show you how to do that. And we're going to install all the outboard components, but our little board here is actually done. So Magnus, thank you for the show. Thank you, Magnus, for hanging out. It was really it was great to have you here. And if you haven't already, follow Notes and Volts on YouTube. You'll get updates on when I'm streaming and all that fun stuff. Facebook, I got a great Facebook community. You know, feel free to join that. Twitter, of course, you know, I tweet out when I'm going to stream, so it's a good way to get in touch with me. Patreon, if you really like my stuff, it's really helpful. And of course, notesandvolts.com, the most fun website on the planet, in my opinion, and I am not biased in any way. Okay, guys, have a great night, and I will see you next time.